Hi, my name's Andy Warner and I'm a Senior Distinguished Technologist here at HPE. And I'd like to take this opportunity to provide an update on where HPE are in their journey of using ARM processors within the HPE product line. As you know, as you probably know, HPE acquired Cray in September 2019, and both HPE and Cray had separate ARM-based initiatives in flight. And also both companies had a long and productive history working with ARM processors. So I just want to provide a brief overview here of that history, and hopefully it provides a little context. So starting in 2012, HPE had a project we called Redstone, and that had used Calxeda low power CPUs, very dense solution. That led that pathfinding work led to a 2014 product. The product started in 2014, I'm sorry, called Moonshot. It's still going today, and that used an assortment of Calxeda, TI, Applied Micro CPUs, and it's a dense solution, provides 45 X-Gene cartridges in a 4U enclosure. And then around 2015, Cray started a program they called Envoy, which used the Cavium TX1, and that provided 4 nodes in a 2U enclosure and used a 40 gig Ethernet fabric. So then we moved to 2016, where HPE was developing a prototype platform we called the Machine, which was used for pushing the envelope in a number of different areas of technology. And we chose the Broadcom Vulkan CPU at that point, which was precursor to the TX2. And we did a lot of work with the Gen Z fabric, which is now an open consortium. We had solutions where we had 160 terabytes of addressable memory. We had fabric attached memory. We had integrated optics. It was a very productive prototype program. And then, sort of in the same time frame, Cray was collaborating closely with ARM from the earliest stages of SVE, and they were sharing their extensive experience, decades of experience, designing vector instruction sets, designing tool chains to exploit those instruction sets, and actually aligning those with production codes from customers. So there's a big difference between just delivering vectors and actually making them usable in a real world environment. So Cray was contributing to the design process for SVE. Then in 2017, HPE had a program we called Comanche, which was a very early access program for the TX2. That led directly to the 2018 HPE Apollo 70 product, which used the TX2 from Marvell. And at the same time, Cray had a TX2-based product called the XC50. This has resulted in multiple installations of both Apollo 70 and XC50s, and of course a notable one here is the Astra machine, which was the top 500 machine. That's about 2,600 Apollo 70 nodes. Fast forward to today, and HPE is proud to offer the Apollo 80, which uses the Fujitsu A64FX CPU. And that provides 8 nodes in a 2U enclosure. And what you see here is one of the 4 2-node sleds that are used in that enclosure. As you're probably familiar, the A64FX implements both SVE and HBM, which is a compelling combination. And this solution supports an InfiniBand fabric. So I want to take a little time as well to talk about the structural differences of the ARM ecosystem that make a difference to us. And I think the clear thing here is the collaboration. Cray and others were able to collaborate closely with ARM on the design of SVE. This, as I said before, has ensured efficient implementation of real-world codes and tools, not just tricks, not just parlor tricks, but real-world codes. And you've literally got decades of experience from Cray and others, both customers and vendors, built into this. The other key thing is vendor diversity. I think you saw this on the last slide. There's lots of vendors there, some of whom are still in the ARM market, some of whom have entered the ARM market and departed the ARM market. Sadly, one of those was Marvell, who departed the HPC CPU market recently. But compelling alternative options are available, and I think this is a really important part of the ARM ecosystem, that as a systems integrator, we have a diversity of vendors to choose from. The other cornerstone here clearly is integration, and that's been key to ARM's success in every market they participate in. The ability for the multiple vendors, again, the diversity of vendors, to choose different integration points, to bring different technology and different market segment choices to the solution. This results in a high rate of innovation because all the eggs aren't in one basket. And I think the proof is in the pudding here, that the ARM-based solutions are aggressively pushing the boundaries as the limits of memory bandwidth and CPU performance are being realigned with HBM and SVE. So I think these structural differences in the ARM market play a huge role in making it compelling. Our focus is on driving open real-world results, and as such, I think both HP and Cray have got a credible history here, where there were hackathons, both hosted as part of the Catalyst program and also as part of various programs with the XC50 from Cray, and specifically the Catalyst UK program was designed to generate results and proof points, real-world proof points for this technology. And the program is winding up now. It was designed to run for 3 years, and it's entering the last half year of that 3-year cycle. And there's sort of a recap in this. I encourage you to seek out the This Week in HPC podcast that was recently a sort of retrospective on the Catalyst UK program. What the participants learned, what it meant to the market, how productive it was. HP is also making the necessary investments in the ecosystem to make it work. And what does that mean? Well, it means designing systems around these products, around these chips. Not just, a single box with 1 or 2 CPUs in it, but designing a system around it. That's someone can come to us and say, I want to buy this many petaflops of CPU solution, of compute solution, and can ARM be a credible solution to that? So the system design and support through our Point Next services are absolutely key to that. We're interested in building commercial solutions, not necessarily science fair projects. So the other thing we can do is we're making sure that the operating system support is relevant for the HPC market. HPE and Cray have got a long history of collaborating with distro vendors like Red Hat and SUSE to make sure that we've got the world-class HPC relevant operating systems available with support options and updates for security, etc., available for the ARM platform. The other thing that we can do now at HPE, since we bought Cray, is we can offer a compelling toolchain and programming environment that is, Cray had the Cray programming environment, and that demonstrates, as you'd expect, because Cray, compatibility with compilers was a big part of Cray's contribution to SVE. As you can expect, Cray PE demonstrates excellent optimization and performance when running real-world problems into SVE compute engines. So we also have the profiling and debugging tools to support that. So I think all of these components are necessary for us to actually have a vibrant ecosystem in HPC, and we're using this to drive uptake. And then the important thing here is to put a marker out there that as a systems integrator and technology partner, HPE's first goal is to provide choice to our customers. And ARM is a key technology in the overall solution landscape for us. So, and I think you've seen, that's not just an empty words. I think you're seeing our commitment to that show through. So I want to give you a quick update on where we are with the Apollo 80. So what this is an A64FX based system which has been enabled by a technology agreement between HP and Fujitsu. And so it clearly builds on the Cray and Fujitsu history of vector processing. Both companies have got a rich history, a rich and long history of vector processing and supercomputing. It provides leadership performance for memory-intensive HPC applications, specifically because of the HBM content. And our solution, the Apollo 80 solution, provides over 40 teraflops of, important to say here, easy to harness compute power in a 42U rack. It sports an EDR InfiniBand fabric, and it's available like any other HPC solution from HPE. It's available fully configured and tested. So, it's factory assembled and tested at the system level, we don't just drop a pallet full of pieces on your dock and say, have fun. It's got a comprehensive software portfolio available, it's got system management solutions available, and more importantly, again, it's got the service and support from HPE Point Next. And so we've got we've got many customers, and I just want to point two out that are, particularly public and particularly open to collaborations here. So these will be Isambard, which is part of the GW4 project in the UK, and there's Apollo 80 systems are part of Isambard. It's a multi-platform testbed and supercomputer. So there's an Apollo 80 component to that now, and together it forms Europe's largest ARM-based supercomputer. And there's another system at Stony Brook, Ukami, that's the largest Apollo 80 system in the world currently. So both of these are installed and operational, so this isn't vaporware. So where are we going? So I want to just take a moment to look forward as well. So HP has already announced 2 customer systems based on the upcoming Grace processor from NVIDIA. And these are both HPE Cray EX systems, and these are designed to address the most challenging HPC and AI workflows in the world. And installation is scheduled for 2023 for both systems. So I think you can see that our commitment to ARM systems is long-lived and ongoing. So I look forward to updating you about the next stages in our journey as we're able to reveal the progress. So thank you, and please reach out to me or anyone from HPE if you want to learn more.